Imagine a fighter jet without a tail. No vertical fins. No additional horizontal wings. Just a single streamlined body darting through the sky, nearly undetectable by radar, and seemingly defying the laws of aerodynamics. That's what everyone is talking about right now. Photos of China's tailless J-50 aircraft. A mysterious design that looks more like CGI than real technology. But behind that strange design lies a major revolution, not just for the military, but also for the world of aviation technology and aerodynamic science. Today, we will discuss it without sensationalism, without politics. We will dissect how innovation, physics, and artificial intelligence work behind this most mysterious project from East Asia. Introduction and global context of modern jet development. Over the past few decades, the world of combat aviation has undergone a massive transformation. From fourth-generation jets such as the F-15 and Su-27, we are now entering the era of fifth and sixth generations, where speed is no longer everything. What matters most now is stealth, system intelligence, and AI integration. Major nations like the United States, Russia, Europe, and China are all racing to create aircraft that are not only fast but also invisible and capable of autonomous decision-making. While the United States has the F-22 Raptor and F-35 Lightning II, China has the J-20 Mighty Dragon, a symbol of their advanced technological capabilities. However, new leaks have emerged. The J-50, a tailless aircraft believed to be the prototype for the next generation. History of the tailless aircraft concept. The tailless design is not actually new. The concept emerged in the 1940s, when engineers such as Jack Northrop in America experimented with flying wing aircraft. The goal was simple: to reduce air resistance and eliminate surfaces that could reflect radar. The most famous example is the B-2 Spirit stealth bomber, a large, tailless, triangular-shaped aircraft that is nearly impossible to detect by radar. However, the B-2 is a large bomber, not a small, agile fighter jet. Adapting this concept to high-speed fighter aircraft is a major challenge, because without a tail, the aircraft would be very difficult to control manually. A superfast computer system is needed to maintain stability every second. That is why only now, in the era of AI and modern aviation computers, designs like the J-50 have become possible to realize. Design analysis of the J-50 and possible technologies used. From the photos circulating, the J-50 has a tailless delta shape. That is, a large triangular wing configuration with pointed tips and a smoothly integrated fuselage. Some of its notable features: no vertical fins, replaced by thrust vectoring stabilization. Twin engines spaced fairly wide apart with concealed air ducts. Possible use of carbon fiber composite materials and radar-absorbing coating RAM coating. This structure not only reduces radar reflection, but also improves airflow efficiency at high speeds. Its sleek shape and lack of tail protrusions indicate that the design focuses on extreme stealth capabilities and supercruise speed. Aerodynamics and stealth principles. Without a tail, an aircraft would lose its natural stability. Therefore, all control forces must be provided by the main wings and computer-controlled adaptive flaperons. This system is called fly-by-wire, in which a computer reads thousands of sensors every second to adjust the wing angle and maintain balance. In terms of stealth, the J-50's design is highly efficient. The vertical tail is one of the components most prone to radar reflection, so eliminating it can significantly reduce the radar cross-section (RCS). Additionally, every surface of the aircraft's body is designed with an angled slope, so that incoming radar waves are reflected in another direction, not back to the transmitter. Radar-absorbing materials, special paint, and even the shape of the engine intakes hidden within the aircraft's body serve as additional layers to enhance the stealth effect. The end result, an aircraft that is nearly invisible to radar and infrared sensors. WS-10C engine capabilities and supercruise. The J-50 is believed to use two WS-10C engines, an advanced version of China's domestically produced turbofan engine. This engine has a high thrust-to-weight ratio and is capable of supercruise, which is flying at supersonic speeds without the aid of an afterburner. Supercruise is very important in modern air strategy. By not engaging the afterburner, the aircraft does not produce excessive heat signatures, making it more difficult to track by enemy infrared sensors. In addition, fuel efficiency is improved, allowing for greater operational range and longer endurance in the air. Two WS-10C engines also provide the advantage of system redundancy. If one engine fails, the aircraft can still return safely. AI and fly-by-wire control integration. One of the most interesting aspects of the J-50 is the possibility of integrating artificial intelligence, AI. With its tailless design, the aircraft requires a very fast and responsive computer system. AI not only stabilizes flight, but can also regulate fuel consumption, calculate efficient routes based on weather and threats, even automatically identify and lock onto targets. This concept is known as AI pilot assist, not replacing the pilot, but acting as a second brain that helps make decisions in a fraction of a second. This technology has been tested on various platforms, including the F-35 and the Loyal Wingman project. This means that the J-50 is likely to become a laboratory for AI-based flight control, which could later be applied to civilian aircraft or autonomous drones. Possible missions and strategic roles. Scientific analysis, non-political. Based on its form and characteristics, there are three possible main roles for the J-50. 1. Sixth-generation test platform. It is possible that the J-50 is not an operational fighter aircraft, but rather an experimental aircraft for testing design concepts, AI controls, and extreme stealth. 2. Long-range stealth interceptor. With supercruise and long range, the J-50 could be a high-speed interceptor to counter long-range threats such as supersonic drones or cruise missiles. 3. AI-based air command. In future scenarios, the J-50 could function as an air brain, controlling a group of combat drones in formation, while the pilot acts only as the main tactical controller. All of these possibilities point to the direction of air technology development, which is increasingly integrating automation, smart sensors, and aerodynamic efficiency. Comparison with other designs, F-22, B-2, YF-23. When compared to the F-22 Raptor, the J-50 appears more minimalist and focused on reducing total RCS. The F-22 still has two small vertical tails, while the J-50 completely eliminates them. With the B-2 Spirit, the J-50 shares a full stealth design philosophy. But the B-2 is a large and slow aircraft. The J-50 attempts to combine extreme stealth with supersonic speed, something that is technically very difficult and expensive. Meanwhile, the YF-23 Black Widow II, the American prototype that was defeated by the F-22 in the 1990s, was a major inspiration for designs like the J-50, as it also had a sleek shape and small, integrated tail fins. In other words, the J-50 does not copy any specific design, but rather combines lessons from various global experiments into a new unique form.